We're talking about graphing rational functions in different forms. And we have example 1 here where we have the function 4 divided by x squared plus 2. So the first thing we want to do is we want to find if there are any x-intercepts. So right here we're going to say calculating the x-intercept. And the way that we do that is we take whatever's in the numerator, in this case it's 4, and we set it equal to 0 and try to solve it. But in this case, 4 will never equal 0, so we have no x-intercept. Next thing that we want to do is we want to graph the vertical asymptotes wherever q of x is equal to 0. So q of x is the denominator. So again, we're going to use the vertical asymptote. And we're going to take whatever's in the denominator and we're going to set it equal to 0 and see what we get. So here we'll have x squared plus 2 is equal to 0. And then we're just going to go ahead and solve that. So subtract 2, then we get x squared is equal to negative 2. And then we can take the square root. And then we get x is equal to plus or minus. And we have the negative there, so it's still the square root of 2. And then we have that I for imaginary. So in this case, we also have none, because it's imaginary there. So our vertical asymptote is none. So we have those graphs so far. Now we got to think about the horizontal asymptote. So we're looking at the horizontal asymptote. That's where our m's and n's come in handy. And we want to decide what the degree is of the numerator and what the degree is of the denominator. So for our horizontal asymptote, here the degree of our numerator is to the 0 power, and the degree of our denominator is to the 2nd power. So the m value is equal to 0, and the n value is equal to 2. So what does that mean? That means m is less than n, okay? M is less than n, that means we have a horizontal asymptote at y equals 0. So here we'll have, this means y equals 0. So our horizontal asymptote will be y equals 0. And then we can sketch that. We can sketch that on our graph. So y equals 0. We have a horizontal asymptote. And then the next thing that we have to do is we have to come up with what the graph looks like. And in this case, we're going to pick some x and y values to substitute in. So we have x and y. And I'm just going to pick some values here. What would be some good values to substitute in here? 0 would be a good one. So 0, if I substitute in 0, I'm going to get 4 divided by 2, which is 2. Try negative 1. Negative 1 squared is 1, so that would be 4/3. 1 would also be 4/3. You can try -2. -2 squared is going to be 4. So that will be 4/6, which is 2/3. And 2 would also be 2/3. And so we can plot those points. So we have the point 0, 2. Let's say we count by 5s here. 5, -5, -5, 5. So we have the point 0, 2, -1, 4/3, 1 4/3, -2, 2/3, and 2 2/3. So we have a pretty good graph, pretty good points, and we know that we're not going to cross the asymptote here, so we can draw, get really close there, come up, and then come back down and get really close again. Last thing we have to do is domain and range. So we didn't have any vertical asymptote. So in this case, because we didn't have any vertical asymptotes, that means it's defined everywhere. So our domain goes from -infinity to +infinity. The range, in this case, there's nothing below the x-axis, and it only goes up as high as 0.2. So we know we're going to start at 0 and we're going to go to 2. Now, the 0 is not included, so we're going to use parentheses. However, 2 is included, so in that case, we will use a bracket. And then we can take a look at what the graph looks like, and we can see it graphed here in the purple. We have our asymptote at y = 0, and then we have the function graphed here at purple with our intersect at 0, our y-intercept at 0.